There we go. All right. So we are basically done with the discussion of multi-digit addition. So before we move on to subtraction, I just want to make sure that you guys have a good understanding of how to perform multi-digit addition in whatever base that we want to use. Okay? So these are some examples, okay? It's already fully worked out, and that's why I'm not going to work on those, okay? Because I want to work on things that is different from what is already given in the class notes. But just out of curiosity, has anyone tried out, these binary addition questions? Not yet? Okay, well, note that I said yet, okay? Which means, I trust that you will do it, okay? Because it is only for your own benefit. I was going through some of the recommendations the last time I got performance reviewed, and one of the comments was, students do not do optional work, meaning, if I think something is beneficial, I have to make it worth points because otherwise people do not do it. So what do you guys think of that? It's mundane, okay, so I can see in one direction. What about the rest of the class? If it is optional, okay, what is going to drive you to do that work that I recommend? What would be your drive? To gain the knowledge, right? It's out of curiosity. It is some kind of intrinsic drive. So, and I cannot teach intrinsic drive. I can only teach the importance of intrinsic drive. Does everybody understand what is intrinsic drive? What does it mean? It means if nobody is watching you, if it's not worth any points, you'll still do it when you have the time. Okay, that's intrinsic. And that is becoming increasingly important in the field that you are getting into, unless you're here only because of curiosity. If you're planning to get into software development or software engineering, the amount of on the fly, on the job, learning that you have to do to kind of keep up with the technology and keep up with, the tools is immense. Okay, you cannot wait for your boss, to give you external motivation to learn something. You kind of have to keep learning by yourself. Okay, that drive has to come from you, from within, in order for you to stay competitive and successful in that career. So I'm just gonna say that because I think it is important. All right. Having said that, I'm going to give you some examples. So for this particular illustration, I'm going to use the base 5, okay? So these examples are based on the base 5 multi-digit addition. So I'm just going to randomly pick a number. It's not exactly random, but it's random enough. Okay, so x is 413 in base 5. Okay, so remember the base is important here. And then the second number, which is y, I'm just gonna throw a number here. We'll just make it a 2, 3, uh, 2, 3, 4 looks good. Okay, so it is important not to read the numbers as 413 or 234 because that implies the numbers are in base 10. Okay, so we have to remember 413 is a base 5 number, and so is 234 as a base 5 number. So now we have to compute, the Q row. So can anyone tell me how the Q digits are computed based on the X and the Y digits? Well, at least tell me where in the notes you can find out, how they are related. That's something that we talked about on Tuesday. Yes, the question is, how do we compute the Q digits? In other words, what is the equation that tells you Q of I is what? Okay, so let's do this step by step. Okay, First of all, did I talk about it? Okay. Two, did you write any notes about it? Okay. Assuming that you did, okay, where did you put that note? Where did you put that definition? Because you should have a dedicated section in your notes just for the definitions. Why? Yes, please. Okay. Uh-huh. Yes. Okay, very good. R of xi, yi. I do not require you to memorize any of this because the exams are, once again, open book and open notes, okay? Which means memorization is worth nothing in the exam. So what I'm really testing is, can you use what you have learned to solve problems in the exam? And those are likely to be problems that you have not seen before. So the first thing you need to do is to make sure that you have the knowledge. This is knowledge, okay? It is in the notes, okay? It is a matter of knowing where to find it. So if you have it written down, that's good. You know where to find it because you wrote it, okay? If you have highlighted the definitions in my notes on a piece of paper, great. You know where to find that too. Okay. Even though it's a little bit harder because I have a tendency to sprinkle definitions all over the place. Not intentionally, but because when I explain things, the definition pops up wherever the explanation leads it. Okay. So when you take notes, you can rearrange, okay, and have all the definitions in one single place because you don't have to explain to yourself, how the definitions, become, the definitions. Okay, you don't need the explanation as much. How is R defined? Okay, in other words, if I were to say, okay, R of UV, how is that defined? Can you find it either in my reading material, the one that I give you, or can you find it in your own notes? So if you are looking at me instead of reading your own notes, trying to find the definition, you might want to consider writing notes now. Okay? So if you're not doing that, I can give you historical statistics, okay, that may not be encouraging. So you might need to consider, taking notes. So how is that defined? I hope somebody can answer that question. And this time, base five, okay? Base five. So, yes. Mm-hmm. Yep. That would be great. This is the version for only base 5 because the one that I gave you in class is for base 10. Okay, and when we switch from base 10 to base 5, this is the only portion that needs to be changed. Are we good so far? Yes? No? And by the way, what is the name of function R? It has a very specific name. It is called, I'll give you the first word and see if you guys can remember the rest. It's called the single digit sum. That is correct. Okay, it's the single digit sum. There we go. All right, so this is all important. Okay, I'm trying to make sure that you guys understand the importance of taking notes. Now you can wait until later to take notes if you are rewatching the video. Okay, but if you're not rewatching the video, it is important to take the notes now. All right, so how do we figure out q of 0, which is this little guy here? We know x0 is a 3. We know y0 is a 4. So according to those two definitions, what is q of 0? It will be 2 because it is 5 plus 4, which is a 7. 7 mod 5 is 2, okay, because 2 is the remainder of 7 divided by 5. So here's a 2. And what about this one here? What about q1? 1 plus 3 is a 4. 4 mod 5 is 4. That is correct. What about the last one? 4 plus 2 is a 6. 6 mod 5 is a 1. There we go. Okay. So now we are looking at the more complicated column, row, which is the K row, which stands for carry. Now, because we are not stacking additions, so that means K0 has to be a 0. Okay, so that one, is a no-brainer. What about this one here? This is K of 1. So now we go back to the definitions. Okay, how is K of I plus 1 defined in the notes? So either one, you have it written down, or you know where to find it. Yes, go ahead. Oh, I thought you know. Okay. Uh-huh. C of Ki. Well, let's make it Qi. Yeah, that order is better. There we go. Very good. So now next thing is, how is the function C defined? Okay. So this time I want this function C to be specific to base 5 and not to base 10. So how is that defined? It is u plus v again, but now you're comparing to 5. If it is greater than or equal to, you return the value of 1. If it is not, you return the value of 0. Okay, so that's the specific version of the C function for base 5. So now we plug in, this is K of 1. So when you try to work out K of 1, what is the value of I in this template? We need to figure out K of 1. So the question really is asking 1 equals to I plus 1. So what does I need to be? This is algebra. Let me let me write it out here. We need 1 to be the same as I plus 1. So what is I in this case? It has to be 0, okay? Because it is algebra. Algebra says if I subtract, equal amount from both sides of the equation, it will still work. So if I subtract 1 from both sides, this side becomes a 0, this side becomes a 1, excuse me, this side, the other side becomes I, so we can solve that I has to equal to 0. So that means if I want to figure out K of 1, that means I need to rely on x0, y0, and I also need to rely on q0, k0, and we have all of those already available. Okay, so in this case, without having me to actually have to plug in all the values to show you, what is K1 in this case? It is a 1. That is correct. Okay, this one has to do with 3 plus 4 is 7, which is greater than or equal to 5. Okay, what about this one over here? What about K2? K2 has to rely on the C of x1, y1 plus the C of Q1, K1. Okay, so in this case, we look at x1, y1. 1 plus 3 is greater than or equal to 5 is false. So it's going to return a 0 according to the C function. On the other hand, if we look at Qi, which is 4, plus Ki, well, K1, sorry, instead of I know it's 1. So Q1 is a 4, K1 is a 1, 4 plus 1 is a 5, and is 5 greater than or equal to 5? Yes. So that means the second portion will give us a 1 this time. The first portion gave us a 0. 0 plus 1 is a 1. There we go. But we know that there's an overall, carry, which is in this case K of 3. So K of 3 is right here at this position. What should that be? It should be a 1. Very good. Okay. So now that we have the Q and the K, we can now compute the sum, which is the last row. Okay. And how is the sum row defined? I'm going to just read it to you. Okay. This is all in the notes. Okay, and it is important that you actually read the notes. Okay, you should read it once before class. You should read it and make sure that you understand all of the material before the following class. Okay, that is my recommendation. which means it is also, guess what? Optional. But should you do it? Well, that is kind of your decision, okay? Because it really is your grade, okay? And it is, you know, it is your choice, okay, to pursue computer science. And I'm saying that this is actually important in computer science, okay? So we plug that in, okay? 2 plus 0 mod 5 is just a 2. 4 plus 1 is a 5. 5 mod 5 is a 0. 1 plus 1 is a 2. Mod 5 is still a 2. And that's it, okay? Because we also talked about how x, y, and the sum, they must have exactly the same number of digits. Because whatever mechanism is providing the values of x and y, or the numbers x and y, is also the same mechanism that will store the sum. And as a result, they must have the same number of digits. So now I can do a cross check, okay, which is also a practice on base conversion, okay, because in base conversion, what is 413, what is the value represented by 413? Do we know which formula in the base conversion module we should use in order to compute the value of 413 in base 5? That's the lab that we did last Thursday, okay? Okay. All right, so instead of a formula, you can also look at it from a slightly more graphical perspective. This 3 here, which is digit 0, is telling us the quantity of what? Base raised to the power of the digit position. This is digit 0, okay? This 1, which is digit 1, is telling us the quantity of 5 to the power of 1. And then the 4 is telling us the number of 5 to the power of 2. That is correct. Okay. So this is how you can just kind of write it out. Okay. You don't have to apply the actual formula. You can always just go like, okay, I'm just going to list out all the things. So now we just have to like look at 5 times 1 is, excuse me, 3 times 1 is a 3. 1 times 5 is a 5. 4 times 25 is 100. These are all in base 10. So we are looking at 108 in this case. Okay. So x is also known as 108, but in base 10. Are we doing okay? All right. So now we look at the other one, which is 2, 3, 4 as a base 10 number. So this time I'm going to go a little bit fast. Okay. 4 times 4 times 1 is a 4. 3 times 5 is 15. So now we have 19. Plus 2 times 25, which is 50. So 50 plus 19 is 68, if I remember, if I did the math right correctly. Okay, we'll double check. Okay, so I'm going to write it over here. So 2, 3, 4. 4 times 1 is a 4. 3 times 15, sorry, 3 times 5 is a 15. 2 times 25 is 50. 50 plus 15 is 65. 65 plus 4 is 68. Are we still doing okay so far? Yes. 4 times 1 is a 4. Yes, because it's 4 times 5 to the power of 0. Are you talking about this 4 over here? Huh? S of 1. You mean this one here? But remember, the S function does not rely on the C, it relies on R. Okay. But that's okay. This is good. Okay. This is good, because, okay, this is another thing that is, something that I want to nag people about. Making mistakes is great. Okay. As long as you don't make the same mistakes 20 times in a row exactly the same way. Okay. Because when you make mistakes, you learn that, oh, okay, I might have misunderstood something. Okay. It's a great thing. Okay, it's great that we understand that. Oh, okay, I made a small mistake understanding this now in the lecture, as opposed to when the test is happening. Okay, so making mistakes is actually a great thing. Okay, all right, cool. So now we perform the actual addition in base 10. I don't. I hope this is not challenging to anyone. Okay, 8 plus 9 is a 7 with a carry of 1. 0 plus 6 is a 6. 6 plus 1 is another 7. And then we have another one here. So it is 177. So now you ask, but Dak, why do we care about 177? Because we already have computed the sum is 202 in base 5. Because this is how I can apply the other way around, the other conversion. And converting 177 in base 10 back to base 5. I should get back to 202 or 202 in base 5. Okay, it is not, well, it's 1202 in base 5. Okay, that's an extra 1 because this little carry here that is hanging, it is still signifying that we have 1 times 5 to the power of 3 as a part of the sum. Okay, because that particular carry is not represented in the sum itself, but it is nonetheless a carry of 5 to the power of 3 because this is digit 3. Yep, yep. All right, so we are going to go through the base conversion in the opposite direction now. I'll be okay with kind of clearing this part. Okay, it really should be because all of this is in the notes. Okay, it should be nothing new. Okay, the question is, have you read the notes? And do you know where to find the definitions and what do they actually mean? Okay, so that's important. Okay, just because we have all the notes and all the formulas and all the definitions does not mean that you can quickly apply those in the exam. Okay, so one thing you might need to do is to make sure that you can quickly retrieve those definitions in the exam. Okay, now that I have already told you this, you kind of have to derive a strategy, right? So that you can find the definitions really quickly. Okay, but I will leave it up to you to find out, how to do that. If you have questions about how to do that, what would be the next step to take? Ask Gemini. Okay. Now, I want you to ask Gemini instead of asking me why. Why am I not a good source of information when it comes to study skills? Exactly. Everybody learns differently. And as it turns out, I found this out, the way that I learn is not very normal. So if I were to teach you how I learn, it may not be applicable to you in general. So you have to kind of figure out what works best for you. All right, so conversion back. Okay, we are now converting 177, which is a base 10 number, back to base 5. Okay, there are a few ways to do it. We'll do it the really, really obscure, well, not obscure, but the really tedious way. Okay, using the one single formula that I have given you in the reading material. Okay, and do you know which formula we are talking about? Where is it located? So I'm going back to my notes because I need you guys to know where to find the reading material so that you can actually read it. Okay, because if you don't read it, I don't know what to say. I really do not know. All right, so we're getting back to base conversion. Okay, so I'll turn on view as student. So now we're looking at this from your perspective. And because it has to do with base conversion, if you're lazy like I am, just type Control C and then look for conversion. There we go. So this one is the lab, and then the base conversion thing is right before that. So open this, and It goes to a particular module. Okay. So now, just out of the outline of the module, where do you think I should go? Okay, first of all, do you think you should read the whole thing? That is correct. Okay, because if this is not intended for you to read, why would I do it? Okay, so you should have read the whole thing. Okay, but once you, even if you have read the whole thing, you might not remember, which portion contains the formula or the equation that can convert the value back into a particular number in a certain base. I think I have just read you the answer. So which section should we go to? Converting. There's only one section that starts with the term converting. We are given a value, which is 177, and we are here to convert it back into a number in a particular base, which is 5 in this case. Okay, so that means the outline of the module is actually helpful, okay, or it should be helpful when you're trying to locate information. It is still better if you took notes, so that you know where how you organize your notes. So the only equation is right here. Okay. So now we are just going to apply that equation where I goes from 0 to 2 or 3, okay, until we run out of stuff that we can do, that we need to do, and then we'll just call that a day. All right. So how do we apply that formula? What is that little square bracket thing that is missing the top? What does it do? I'm talking about this symbol here. What kind of operator is it? It is called a floor operator. Okay, so those are the things that we have talked about. Okay, so it is important to kind of make sure that you know where to find the definition and also the equations themselves. All right, so we're going to work the other way around. We'll start with I equal to 0. So we are looking at d of 0. It is the floor of 177 divided by 5, because that's the base raised to the power of 0. And then the whole thing is going to have to mod 5 after the division. So now we just have to go like, oh, 5 to the power 0 is just 1, right? So that means we have the entire 177 mod 5. Now, I don't need a calculator to know that this answer is going to be a 2, because 177 mod 5 is going to be a 2. What is the trick to do that? It only works for base 10 numbers. Hmm? All whole multipliers of 5, or all multiples of 5, okay, would either end with a 0 or a 5 in base 10. Okay, I'm just curious because I need to know where you guys stand. Did you guys learn that in before coming to college? Okay, very good. So because of that, I can just quickly look at this number and go like, oh, okay, the largest number that is less than or equal to 177 that ends with a 5 or 0 is 175. What do I need to go from 175 to 177? 2. So that's how you can use mental math really quickly to figure out this is just 2. What about d of 1? Kind of the same deal, okay? But this time you have to divide it by 5 to the power of 1, and then take the result of that and then mod that with 5. So what is the quotient of 177 divided by 5? 35? Okay, I think it is 35. Yep. And what is 35 mod 5? It's a 0. There we go. So just to let you guys know, you can bring a calculator to the exam, but I really doubt that your calculator has a mod function. Some do, but I don't think most calculators has a mod function. So you kind of have to look into how to figure out the mod or the remainder of a division when your calculator does not have a mod key. Okay? Once again, how do you figure that out? You can program one. You can also Gemini and figure out how to do it. I would just do it, by mental math, but that's just me. So once again, the way I do things may not be the way that you prefer to do things. Okay, I can do a lot of mental math because, not because I'm smarter. Okay, trust me, I don't want myself to be smarter than you guys. I may know more, but I probably is not smarter. What is the difference? I know more than you guys do. You would certainly hope that is the case, especially related to assembly language programming and computer architecture, right? But I don't think I'm smarter than you guys, okay? Because being smart, being intelligent has to do with given the information, how much can you do with it? It is not about how much information you know natively. It is about if I give you the information, what can you do with that information? Okay, so um, I think it is important that every generation becomes smarter than the next one. Otherwise, AI is going to take over the world. I'm not kidding you. I was just watching an old movie. Some of you may not even know that movie because it's that old. Wally, WALL-E. Okay, okay, you guys are still nodding. By the time I retire, I'll be mentioning that movie, and then all the students will go, like, I don't know what you're talking about. Have never heard of that movie. So I was just watching Wally, and I think if each generation is not smarter than the previous one, we'll end up with auto, quote unquote, literally driving the boat. Okay, that's what happened in the movie until the end of the movie. Okay, what about D of two? Okay, we'll finish this up. No, not yet. Okay, this is just one of the last ones. Okay, so now we are looking at 177 divided by 25. I just need to know the quotient. What is the quotient? Yep, it is 7. Okay, very good. Because 6 times 25 is 150, and there is another 27 to go, which means we need one more 25 to make up for that. Okay, so it is indeed 7. 7 mod 5 is a 2. Cool. So until we get a 0, we really should not stop just yet. So now we have to go to D of 3. So we look at D of 3, it would be 177 divided by 5 to the power of 3. Take the floor of that and then mod it with 5. Okay. So what is that? What is 5 to the power of 3? 125. Very good. So you look at 177 and then you look at it, you're trying to figure out the quotient of 177 divided by 125. That should be a no-brainer. It would be 1. Okay. 1 mod 5 is a 1. In other words, I did not make a mistake, or I do not think so, in this calculation. This one here is actually our D3. This is our D2. This is our D1. This is our D0. All right. So just by working out one example, I forced myself to go back to all the definitions, apply the definitions, go through base conversion from base 5 to base 10, go through the conversion from base 10 back to base 5 to verify the answer. Okay, so I can do all this as quote unquote optional work, but this helps to make sure that I'm understanding the material correctly because everything is consistent. Okay, noticing that everything is consistent is important because the moment you see anything that is inconsistent, you should always stop and ask, why is this not consistent? Alrighty. So now that we are done with this, I will leave it to you guys to figure out the base conversion problems at the end of the module. And the answers are already in it. Okay, if the answers are actually human generated and not AI generated, so they should be correct. Okay, but if you think something is incorrect, bring it to my attention so I can double check to make sure that I did not make a mistake. Because when I was generating these problems with AI, the language models were not quite as good as reasoning, so they make all kinds of mistakes. Okay, they made all kinds of mistakes. I think they're better now, okay, but I cannot be sure. But all of these were actually worked out by hand, so they should all be correct. All right, so now we can move on to, okay, drum roll, subtraction. Yeah. So just like with addition, we are going to start with base 10 multi-digit subtraction. So let me go to my mouse pad because I can just use mouse pad to work this all out. And there we go. All right. So we are going to start with base 10, as an example. So we'll go with, I don't know, let's try 561, and we'll subtract from that. Let's just say, 600 and let's see, mm, 662. Okay, that's what I'm going to choose to use in this case. Okay, all right. So now we're going to name, the rows. This is again X, this is again Y, and then we have Q again, okay? But this time Q is defined a little bit differently, okay? This is what I call T for taking away or take away. So it's just a name, if you don't like T, just, yeah. And then the last row is going to be D for difference. Okay. So now, just like before, this particular digit here is going to be the single digit, not sum anymore, difference of 1 minus 2. So what is the single digit difference of 1 minus 2? In a multi-digit subtraction, okay, when you see 1 minus 2 on the column, what do? You borrow from the next column, which makes the 1 a 11, right? What is 11 minus 2? Is a 9. Very good. Okay. So in this case, the single digit difference is a 9. Okay. And I just answered my own question. Okay. We do have a borrow here. So we put a borrow here. This is always going to be a 0, at least for the time being. Now we work on 6 minus 6. 6 minus 6, that's an easy one. It's got to be a 0. But I don't know whether to put a 0 or 1 here. So we'll work that out later. We have 5 minus 6, which is once again a 9. And we're going to need a borrow over here. So the question is, what do I put here? 6 minus 6 does not need a borrow, but when you look at the Q and the T, it does need a borrow. So that means, T of 2 needs to be a 1. Okay, so I need to put a 1 here. Now we look at D. So D is like S. Okay, it is the single digit difference of Q minus T. So that means I'm looking at 9 minus 0, the single digit version of that. That's a pretty easy one. It's just a 9. And now we're looking at the single digit difference of 0 minus 1, which is 9 again. It is just 9 because 0 is less than 1, so we need to borrow, and that's why T of 2 is a 1, because 0 minus 1 requires a borrow. When you borrow a 10 from the digit that is next to it, then you have 10 minus 1, and that's why we have a 9. Okay, so now we go to the next row, which is this one here. 9 minus 1 is an 8. There we go. And you guys look at this subtraction, you go like, no, that is wrong. It is very wrong. Because 561 minus 662 should be a negative number. How do we end up with a number that is bigger than x itself? But wait, there's a borrow. Okay, there's an overall borrow of how much? What is the magnitude of the overall borrow, which is also known as T3? It is 1,000. Okay, so this is kind of like, you have $561 in your pocket, and you want to buy something that is worth, $662. You go like, I really want that thing, but I don't have enough money in my pocket. So what do? You go to the bank. You go to the bank and you borrow $1,000. Okay, you borrow the $1,000, so you end up with $1,561, combining what you borrowed and what you had to begin with. And then you go purchase whatever you want to buy, which is $662. So now, how much money do you have left in your wallet? You have $899. But you kind of have to remember that you owe the bank $1,000. Okay? So when people ask, what is your net worth? What is your net worth? It'll be 899 minus 1,000, which is going to be 101. So your net worth is negative 101, which is also what you're supposed to get when you subtract 662 from 561. Are we doing okay so far in terms of the concept? We good? I hope so. Okay. So now we're going to move on to talk about, how is R going to be defined in this case. So for before people start to complain and go like, but this is confusing. Okay, why are we using R again? It has to do with the binary version of the single digit sum and the single digit difference are basically the same thing. Okay, but we're not going to see that just yet. Okay, so one way to do the R is kind of blindly, adding the base first, and then you do the subtraction, and then you do the mod. Okay, so it's one way to do it. You can also use a ternary expression if you want, but I'm just going to do it the brute force way, which is 10 plus u, the whole thing, minus v, and then take this entire thing and mod it again with 10 again. Okay, not the best way to do it, but it's one way to do it. Now we look at borrow. Okay, we're looking at the subtraction. Okay, once again, u and v, the parameters, are representing single digits. So the range of value of u is from what to what? We're talking about base 10, a single digit. So u has a range of 0 to 9, and so is v. Okay, so we just have to keep that in mind. So the borrow is actually easier this time. It doesn't even care about the base. Okay, we just have to know whether u is less than v, because if that is the case, we need to borrow from the next digit. Otherwise, we do not need to borrow. Are we good so far? All right. So these two definitions are actually in the notes too. Okay, there it is already in the notes, but you should probably be writing it down at the corner. Just kind of reserve a corner for all the definitions, just so that it's easier for you to locate it. All right. So if that is the case, how do we relate the digits? Well, earlier we just kind of figure out already. Okay, because earlier we already said Q of I is the R of xi yi. It is the single digit difference of xi minus yi. So in this case, because in subtraction it is not commutative, it is important for us to identify x and y carefully, because in addition, x plus y is the same thing as y plus x, so it doesn't really quite matter, the ordering of the parameters. But in this case, because subtraction is not commutative, the ordering is important. I just threw a word at you. Do you remember? Do you know what is the meaning of commutative in algebra? Hmm? No, it is not sum, although sum is related to the concept. That is correct. You cannot exchange the position of the operation. Okay, so x plus y equals to y plus x. That means addition commutative. X times y is also the same as y times x. So that means multiplication is also commutative. Subtraction is not. because x minus y is not the same as y minus x. So that's why in this case it is not commutative. So when things are not commutative, it helps to give things names. So instead of keep calling the left-hand side versus the right-hand side of a subtraction, we'll just call these the proper names. Okay, the left-hand side of a subtraction is called the minuend, and then the right-hand side is called the subtrahend. Hmm? Sorry? Yeah. Yep. It is actually the case. So, and these are the things that you can also look up too. Okay. You can see, what is my favorite friend here. Okay. So we'll just go ask Gemini. So you can literally just ask it that way. Okay. How do we call the left hand side of a subtraction? This is why AI is dividing people even more than before AI. People who want to learn more, they learn more faster. And people who want to use AI as a shortcut, they are learning less and less. Okay, they're exercising their brain, their minds, less and less. So the left-hand side is called the minuend, and let's see whether AI, the Gemini, is smart enough to know what I will be asking next, or automatically answer the question about the right-hand side also. There we go. It actually tells me that the right-hand side is called the subtrahend. The result is called the difference. Okay. So what I'm illustrating here is AI can be very helpful, okay, because it can help you learn more quicker and more effectively. But at the very same time, for people who use AI as a shortcut, it can be very bad for learning as well. Okay, so you kind of have to evaluate, how you want to use, AI, as a student. All right, moving on. So moving on to Q of I, we got to figure out, okay, now we have to work out the T of I. So T of I is the quote unquote take away or borrow, but I don't want to use B because I use B for the function already. So T of I plus one, okay, I should be careful here because T of I plus one, I'm going to use, the square bracket here just so that we know I plus one is the subscript of T. So this is the B of Xi, Yi plus the B of Qi, Ki. Okay. The reason why that is the case is because T of 1, okay, this T here is because of 1 minus 2. But T of 2 is because of Q minus T. So we know that there are two sources to have a to have a borrow, excuse me, to have a borrow of 1. And, and that's why we have a plus here. Now, for people who recognize the structure and go like, that looks like something that we have learned about addition, because all we have to do is to change all the t's to, um, oh, I just made a mistake. I made a mistake here because there's no k in here. There's only t. Okay, so if we change all the t's to k's and we change all the b's to c's, you go like, but that's the same thing as addition. We're just kind of switching a few letters and we're done. And that is correct. Okay. So if you have noticed the structural similarities, congratulations. Okay. Because that ability to understand and also to recognize structural similarities is what will allow you to do abstraction. Okay. Remember, we talked about abstraction, I think, just on Tuesday. That is abstraction. Okay, if you can recognize those similarities and go like, hey, if I just replace this letter with this letter and then replace that letter with that letter, it's really structurally the same as something that we have seen before. That is an important skill. Now that I don't know how to teach. I think part of that is innate. So you can actually ask Gemini. Oh, I'm not kidding you. You think that I'm kidding. I'm not. Okay, so in Gemini, you can now ask, how do I train my uh, abstraction skills? Because it is important. Okay, so let's see what it has to say. And if you click on the drop down here, it's actually quite interesting. It is the inner thoughts of the AI. Okay, so let's check out the answer here. Training your abstraction skill involves practicing and the ability to zoom out to see the big picture and zoom in to see the concrete details. It's about learning to strip away the noise to find the signal. That is not super helpful. Okay, as a child, do you guys have those games where you are presented two pictures and they are very similar, and then the question is there are like five differences between the pictures to find the differences? That is the training. Okay, if you have been doing that a lot as a child because you derive joy out of it, you have been training yourself with abstraction skills all along. Okay, because that is what abstraction is about. Okay, you're comparing two things, you overlay one top on top of the other, you notice what is the same. Okay, that's the structure, and you notice what is different, and that is quote unquote the noise in this particular explanation. The signal is what is the same, the noise is what is different. Are we okay so far? Okay. So if you want to go one step further, you go like, okay, this is great instructions, but I need actual exercises that I can do in order to train my abstraction skills. What would be the next prompt? Generate examples, okay? Generate examples that will help me strengthen my abstraction skills, okay? I am not kidding you. Okay, this is literally what you can do today, and since you all have access to Gemini, all you have to do is to sign into your W account, using the district, single sign in, and then go to gemini.google.com. You have, the district, not the district. The state chancellor's office has already paid for your Gemini subscription for the next 2 years and a half. Okay, so use that resource. I bet you some of your other professors haven't told you that. They Everybody has a different view on AI. Some professors do not see AI the way that I do, but I think, if I tell you how to use it in a proper way and you choose to use it in a proper way, it's going to be beneficial. Okay? All right. So, moving along. I know some of you guys are getting a little bored because I can see you're texting on your phone. Okay. So D of I is R of QI TI. There we go. So do you see the similarity between addition and subtraction? It's just a matter of, oh, okay, we're just changing the letters, okay? And obviously, the definition of R and the definition of B are different from the definition of R and C a little bit earlier or on Tuesday, but nonetheless, the structure remains the same. Okay, so if the structure remains the same, that means maybe some of the other things will be the same too. But before we get there, now we have to ask, okay, this is great. Okay, now we know the structure behind base 10 subtraction or multi-digit base 10 subtraction. But this class is about the base 2. Okay, we want to do everything in binary, okay, in zeros and ones. So now you ask the question, uh, how do we turn these to work with base 2 numbers? Yeah, go ahead, all the way to the back. Change all the tens to the to a two. Exactly. Okay. So now we're asking, okay, what about base two? So to do this in base two, I'm going to copy and paste. Okay, so we'll do it the lazy way. We'll do the copy and paste. And I believe I can do a search and replace within the scope. So we'll see whether we can do it. Find and replace. And we are, oh, that is not what I wanted to do. Okay, we want to search for 10, replace it with 2, and we only want to do it within the selection and say replace all. No, that didn't work. Let's do it one more time. Maybe I have to use the shortcut key. I don't know. Nope, it just doesn't want to do it that way. Hmm. Okay, we'll do the shortcut key this time, which is Control R. Nope, still doesn't want to do it. Ah, okay, frustrated. Oh, now I can do it. Okay, okay, now we can give it a try. Nope. Okay, so something is not working right here. All right, fine, we'll do it manually. All right, that's it. Okay, now we have the base 2 version of multi-digit subtraction. Okay, do you notice that this is almost exactly the same structure as Tuesday's lecture? Do you notice the, do you have that deja vu feeling? Now, excuse my French. What does that term, that phrase usually means? Excuse my French. Yes, but I did not. Okay, deja vu definitely is not cussing. Maybe someday it will be. Who knows? We just have to convince the AI that it is cursing and teach more people that it is cursing, and then it becomes cursing. All right. So with this, okay. So now that you recognize a pattern, okay, this is also important. Pattern recognition. Why is that important? Okay. Abstraction is the extraction of patterns. So what is the big deal with the patterns? Because if you recognize a portion of a pattern, then you can say, oh, if this is following this and this is following this, that is going to happen next. So that means, if you follow the structure or the pattern of the lecture on Tuesday, you probably know what I'm going to do next. And what would that be? What did I do at about this same point in binary addition? I gave you the truth tables. Okay, I gave you the truth tables. So I'm going to do the same thing here. Okay, so I'm going to give you exactly the same thing. We're going to have u, we're going to have e, we're going to have r of uv here. Now remember, this time it's in base 2. So u can be 0, v can be 0. What is 0 minus 0, and then the whole thing, what is 2 plus 0 minus 0, take the whole thing and then mod it with 2. It's just 0 because it's 2 mod 2, which is 0. 0 plus 1 is 1. Or, okay, I take it back. 2 plus 0 is 2. 2 minus 1 is 1. 1 mod 2 is a 1. What about this one? 2 plus 1 is a 3. 3 minus 0 is 3. 3 mod 2 is a 1. Ah, okay. That is interesting. What about this one here? 2 plus 1 is a 3. 3 minus 1 is a 2. 2 mod 2 is 0. Okay. So this is again, checking whether you have taken notes. Do you recognize this? Isn't it exactly the same U truth table? I mean, R truth table for addition? That is why I chose the same letter for that function, because they are the same, but only in base 2. Okay, in other bases, they're not the same, but in base 2, they are indeed the same. So that means this R function can be implemented exactly the same way as before. So that means R of uv is the negation of u and v, or u and the negation of v, like that. Okay. None of the parentheses are actually needed because of the operator priority in C++, but in case some people do not know the operator priority, this makes the priority very explicit. There are no two ways to interpret the order of operations here. But it's exactly the same thing as addition. Unfortunately, borrow is not quite as nice, okay? So if you look at the truth value of the b function, it's like, it's not quite what we want. 0 minus 0 has no borrow. 0 minus 1 does have a borrow. 1 minus 0 does not have a borrow. 1 minus 1 also does not have a borrow. So you go like, that's not the same thing as a conjunction, but it's pretty close. So what do you think the B function can be implemented using logical operators? It's in the notes, okay, but it's also on the projector right now, or at least you can you can you can recognize some of the earlier expressions and go like, oh, the answer is kind of staring at us in the face because that expression that we have seen already, we just have to copy a portion of it. So what do you think is the answer to this question? What is the B function? How is it defined using Boolean expressions? Okay, first of all, do you remember how I came up with not U and V? Okay, because it generates a 1 only for the second row. And the reason why we have U and not V is because it generates a 1, but only for the third row. Over here, we don't have a third row. The third row doesn't matter, but the second row is still here. So that means, oh, we can just copy and paste. Okay. So the reasoning or the rationale of how these things are derived is actually in some way more important than the result of the derivation. Okay. What do you think is the chances that your employer will require you to go through this kind of derivation? I can tell you it is zero. Okay. Because they don't want to pay you to do something that is already known in computer science. They are paying you to do things that is not known yet or it is not solved yet. So it is the process of thinking that is important. The result is important in the context of this class, but in the context of your continued education, it is the process that is more important. All right. So we got everything here, or just about everything. So now we're going to take this and go like, okay, what about that whole thing of the plus, okay? Because we still have a little bit of a problem with this little plus here, because if this is still an arithmetic operation, we still cannot translate everything to be done using transistors, okay? So now we have to go through the same logic or similar logic as last time and basically say if b of xiyi is a 1, that should guarantee b of qiti has to be a 0, and the other way around, which is if we assume that b of qiti is a 1, that should guarantee. It's okay. It's okay. Are you okay? All right. So if we assume b of qiti is a 1, it should end up with the conclusion that b of xiyi should be a 0. Okay. So let's see whether that works out or not. Okay. So now we are trying to apply that logic. And we say, okay, what if we know that xiyi is a 1? Okay. What does that imply? Well, according to the b function, the only time it returns a 1 is when the left-hand side is a 0, the right-hand side is a 1. That is what we can conclude like for sure. So that means in this case, I can conclude the value of xi has to be a 0, and we can conclude that the value of xi has to be a 1. Since I'm not writing, I'm going to use uh, okay, extra parentheses. We're confirming that xi is a 0 and yi is a 1. Okay, what does that imply in return? Well, I'm going to give you a clue. Okay, can we have a conclusion about q of I? Okay, in other words, can I say q of I has to be something? How is Q of I defined? Q of I is the R of xi yi. We know that xi is a 0. We know yi is a 1. So that means we know that Q of I has to be, okay, let me roll back. Okay, we know xi is a 0. We know yi is a 1. We know qi is the R applied to xi yi. According to the truth table of the R function, if the first thing is a 0, the second thing is a 1, the result has to be a 1. That is correct. Okay, so we know Q of I has to be a 1. Okay, so if we know Q of I has to be a 1, then we go like, okay, so that means the R of QITI, excuse me, the B, okay, the B of RI, QITI, the B of QITI is the B of 1 and then some unknown, right? So we look at the truth table here and we say, we know U, which is the first parameter, is guaranteed to be a 1 because it is QI, right? So that means, oh, it doesn't even matter what TI is because the result of the B function has to be a 0. Does that make sense? So that means, oh, we now know that B of QI TI has to be a 0. Okay, that solves half the problem. So now we have to go the opposite way. Okay, to go the opposite way is to say, what if we know P of Qi Ti is already a 1? What does that entail? Well, borrowing the same structure, we know that Qi has to be a 0, and we know that Ti has to be a 1. Okay, so knowing that Qi is a 0, what do we know about Xiyi? Not a whole lot, okay? But according to the equation, if we know that the R function is returning a 0, that means the xiyi, they have to be the same. Either they're both zeros or they're both ones. Does that make sense? Okay, so we have two cases in this case to explore. So we now say that, okay, so in this case, we can end up with xi being a 0 and yi being a 0, or we can end up with xi being a 1 and yi being a 1. Those are the only two possible cases. So now we look at each and every possible cases here. So we use, okay, just kind of imagine there's an implication going downward. So if xi is a 0, yi is a 0, what happens to the b of xiyi? Okay, so b of 0, 0 is a 0. Okay, so that means we come to the conclusion in this case that b of xiyi has to be a 0. What about the other one? What if xi is a 1, yi is also a 1? The b function applied to xiyi would be the last row of the b function. So that means, oh, b is going to return a 0 as well. Okay, so that means regardless of whether they're both zeros or they're both ones, b of xiyi will return a 0. And therefore, we have a conclusion. So we have the conclusion of if b of qiti is a 1, it is guaranteed that b of xiyi is a 0. Are we doing okay so far? So you ask, what is this? We were never taught this, okay? So what is this kind of process? How do you describe this kind of process? It is the application of logic, okay? It is logic. It's a relatively rigorous application of logic, but that is actually the foundation of computer science. It's the foundation of many classes that you will take in computer science. Are we good so far? Okay, so we are looking at the pattern again, right? We're looking at what we did on Tuesday, and we are matching everything up to this point. What was the next thing that I did on Tuesday? It's related to a truth table, right? So the next thing that we want to do, remember why we go through this whole process, okay? The whole reason why we're going through this process is is because of this annoying addition here, okay? Because if this operator remains to be an addition, I can't do the whole thing using transistors, okay? So what did I do on Tuesday about the same addition, but for addition itself, for the calculation of addition? What did I do? I gave you the truth table, right? I gave you the truth table of b of, well, in this case, it would be b of xi plus b of qi ti. So let me go ahead and give you the truth table again. Okay, so we're looking at b of xi b of qi ti, and then we have b of xi plus b of qi ti, and then we have b of xi, whoops, uh, or b of qi ti. Okay, I hope you vaguely remember this table, except the letters are changed a little bit. Instead of a B, we had a C for carry. Instead of a T, we had a K also for carry. All right, but the whole thing is, they are not truly independent. Okay, if they were truly independent, then we would have to use all four rows of the table, and then we cannot replace the addition with a OR. Because in this case, this is a 0. This one is easy. It's a 1. This one is a 1. Ugh, this one is a 2. Okay? But if you look at the OR, we only have 3 rows of matching. Okay? This is a 0. This is a 1. This is a 1. Unfortunately, this one is also a 1. So what this means is if we can get to the last row, which means B of xi and B of qi can both be 1s, I cannot use an OR. Okay, I have to use addition because the 2 as a result here does not equal to the 1 over here. But what I have just proven is it won't happen because what I have just proven is if B of xi is a 1, it guarantees B of qi is a 0 and vice versa. So that means the last row is guaranteed not to happen at all. So without the consideration of the last row, in other words, I can remove this row from consideration because B of xi and B of qi are not truly independent variables. The link is q of I because q of I is computed using xiyi. That means the result of the two B functions are not independent. There is a dependency between those two. So without the last row, you look at each column, this one versus this one, you go like, oh, now they're exactly the same. Which means now I can go back to uh, the definition of T of I plus one and change this plus and go like, oh, we don't need a plus here. We can replace it with an or. Okay, what is the significance? What was the what was the um, what was the eureka moment on Tuesday? What was I excited about? I don't know about you, but I was excited about it. What was it? We can do everything using Boolean operators, but we only use 3 Boolean operators here, which is negation, conjunction, and disjunction. And on day one, almost day one, of this class, we established that negation, conjunction, and disjunction can all be implemented using NAND, N-A-N-D, negated AND. And then we also established that NAND is only using 2 P transistors and 2 N transistors. So that means now we have the whole scheme of only using transistors to also perform subtraction. Okay, are we doing okay so far? Is everything linking? Okay, so one thing you can do, okay, is to have a concept map. Write down all the concepts, okay, as bubbles, and then you draw arrows, okay, between the concepts, between the bubbles, and the more you can trace back, to all the way to the beginning, that means you have a deeper understanding of the material. Okay, so that is the difference between a deep understanding of something versus a shallow understanding of something. A deep understanding of something means you can track down those concepts mentally without having to read anything. You can track all the way down, or as far as you can, okay, deeper to the more elemental concepts. A shallow understanding means you can go through one or two hops and then you stop and then you go like, I don't know where to go from here. Okay, that's the difference between a deep understanding of something versus a shallow understanding of something. So why is a deep understanding useful in computer science or in any field in STEM? Why is that important? You can reapply your knowledge in a flexible way. Okay, the key is flexibility. How many people have heard about the term of a thinking box? Okay, let me flip it the other way because we don't talk about thinking a thinking box. We do talk about certain people being able to think out of the box, right? What does that phrase mean? What does the phrase mean when people say, "Oh, so and so can think out of the box"? Hmm? See certain solutions or be able to find certain solutions that most people cannot find. Okay, so the question is, who put the box on your in your mind, and how did it get there? It's shallow understanding. Okay, it is shallow understanding. So if in okay, let's just say you're doing a calculus thing. Okay, you're trying to understand something in calculus, and your professor gives you a bunch of exercises to work on. They all have the same format, they all have the same structure. The only difference is minor. Okay, different constants and different, variable names and whatnot. So what your mind is doing is it will extract the structure, but that structure does not actually represent the flexible knowledge that is behind it. But to your mind, you go like, oh, two follows one, three follows two, four follows three, and then once you have done this like 20 times, your mind goes like, okay, two can only follow one, three can only follow two, four can only follow three, because that's the only pattern that you have seen. Now, on the other hand, if your professor gives you some homework assignments where sometimes four is following two, five is following one, and so on and so forth, then you won't have that mindset anymore. It has to be one, two, three, four. Is that okay? So that is how we have boxes in our mind when we think. At least that's my theory. I'm not a psychologist, so I definitely am not certified to give you guys, actual conclusions about this, but these are my hypotheses. Okay? So what you need to do is to make sure that you stay flexible and you basically look at these things at a very elemental way. Instead of looking at the overall pattern, it's like, oh, I always see one, two, three, and four, and I always see one, two, three, and four. So I just memorize one, two, three, and four. Don't do that. Figure out why two can follow one, but leave it open to say that, well, other times maybe something else can follow one. Okay, figure out why three is following two. So you understand that three can follow two, but it doesn't have to be the case. That is the key. Okay, the key is to, okay, there's a certain name for this type of thinking too. What is it? Instead of always thinking, okay, one, two, three, four, one, two, three, four, I wonder whether other things can follow one. Or I wonder why two is following one in this case, or why two can follow one. What is that type of thinking? Starts with a C. Critical thinking. Okay? So critical thinking is one of the few things that AI is really kind of lagging behind. Um, And if you develop, critical thinking skills, it'll be very helpful, if you're pursuing something in computer science. If you have never heard of that term, critical thinking, what are you going to do now? First, write in my notes. Okay, write in my notes, and it's going to say, look up in Gemini what is critical thinking. Okay, and then after that prompt, what is the next thing you're going to do? Ask Gemini for exercises to train your critical thinking skills. Okay, because that's actually important. Okay, do you think critical thinking is useful outside of this class? It's like, it's only something that tech is going to teach us, and it's not important after this class. Why do I want to learn it? I just want to see out of this class, be done with it, and move on to the next class. So why do you think critical thinking is useful? When was the last time you got a bug in a C++ program that you just kind of have to go like, oh man, what is happening here? Yes, you can use it to fix your car. Exactly. Okay. One morning you get to your car, you turn the ignition. Okay. Yes, yeah, I have an old car that still has an ignition to turn. Okay, nobody's responding to that joke. I guess we all drive older cars. Okay, that's okay. That's cool. So you turn and then there's nothing happening. Okay, let's assume that you have a gasoline car. What are you going to do next? There are a few things to check. You start with the easiest, right? Yes, check the battery terminal because you open the hood, it's staring at you in the face. Okay, so you have to use critical thinking. It's like, how does the starter motor get the energy to turn? Now, it also depends on whether it is giving you the ticking sound. Okay, if your dashboard is blinking, okay, that means most likely your battery is weak or the connection is corroded. Okay, on the other hand, you see absolutely nothing on the dashboard, that means your battery is completely dead or there's a disconnection. Hmm. Yep. Yep. So what if your starter motor is actually turning and you hear vroom, 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 and then nothing turns. So what do you do next? What is needed? Okay, the way to think about this is, what do I need for the engine to run? Okay, I'm not teaching automotive technology here, but I'm trying to help you understand the train of thought. Okay, you think about, okay, the engine is turning. Okay, if I have everything that I need, then it should have ignition and then the engine should run. Okay, it should start. So now you ask, what do I need in order for the engine to run? What is providing the energy to keep the engine running and running? You need air, you need fuel, and unless you have a diesel, you also need ignition. You need a spark. So now you know, okay, I need to check my spark plug cable, maybe the spark plugs, maybe the distributor. Okay, those are all related to the spark. You need to check your fuel delivery. Okay, the fuel line. You need to check the air, which is usually not the case, but it can be a case. But the line of thinking is to think about necessary conditions. In order for something to happen, think about all the necessary conditions, check each and every single one of them to make sure they are all met. Okay, that is critical thinking. But in order to diagnose an engine, not starting, you kind of have to understand how it works to begin with. It's the same thing with programming. Okay, I had been a TA, a teaching assistant at UC Davis. I have seen people, look trying to debug a program at UC Davis, and guess what they did? Okay, this is back in the time where there's no chat GPT. And they did not ask the professor because most of the time you cannot find the professor at the UC. And the TA only appears once in a while because the basement is stinky because everybody is working overtime. So what my students did was making random changes to the program, hoping that one of those changes is going to fix the problem. But what actually happened is they're making the problem much worse than it was because some of those changes was actually making things that used to work not work anymore. And because they don't have a track, they cannot track the changes, they could not even undo the changes. It's not like they use GitHub. It's like, okay, this is the last known working version, and I'm just going to make some random changes here. Nope, it's not working. Revert it back to the last working version and try some other random changes. No, they just keep stacking random changes on top of random changes. Okay, that is a lack of critical thinking. Okay, all right. So I know we are running out of time. I'm gonna give you guys the code to today's lab. So I have to get out of student view first to get to that. Alrighty. So today's lab is addition. Okay, looks like I accidentally released it already. Okay, only 7 points. It's not too much. I'm going to the yeah. I have this one is built a little bit differently, so I have to get to a different screen to get the access code. So now we get to settings, and here's the access code. There we go. So the access code is XYQKS. If you have no idea why it is XYQKS, I highly encourage you to study a little bit more. Alrighty, so I'll see you up there in the lab.